Moving on to the second type of problems, you're not just multiplying one equation, but you'll find that you have to multiply both equations for this to work out. So I'll pinch and I'll zoom in so we can take a closer look at number 1. And I'll mark this up. But if I were to try to go from 3 to 2, I can't without using ugly fractions. Same for 4 to 3. And then maybe you'll want to look at it from the opposite direction too. That's kind of the same deal. It's not like I can multiply just one. So let's work with the one that I don't want to do. So I don't want to get 4 and 3 to match up. So here's 4. I know that I could double 4, which would give me 8, or triple it, which would give me 12. So it's kind of like just multiplying. And then likewise, with 3, I could get 3, 6, 9, and then 12. So if I multiplied the first equation by 3, and this equation by 4, both of these would become 12, and it would really let myself eliminate. But I am only showing that to prove that you have two choices, but I'm going to not make that choice because I think that as I look at the first equation, doubling it and then tripling the second equation, that's going to make life a little bit easier and have not so large of numbers. Okay, now we always have to rewrite these. So here's one. 3x plus 4y is negative 25, and then I have 2x minus 3y is 6. And what I said was we can double the first one and then triple the second one, but I'll also want to multiply it by negative so that it becomes the opposite. So my first equation, after I skip a line, becomes 6x plus 8y equals negative 50. My second equation becomes negative 6x plus 9y equals negative 18. And when I go and I add these two together, I'll end up with 17y equals negative 68. Now you probably don't have a warm fuzzy feeling yet because these are kind of ugly numbers. But if you ended up typing this in your calculator, or if you can recognize that that's negative 4, then you feel a little bit better about it. And when I plug it in, I'll plug it into, I guess, the first equation. So I'm writing 3x plus 4 times negative 4 equals negative 25. 3x minus 16 equals negative 25. Add 16 to both sides, and I get 3x is negative 9. Divide by 3 and you get x is negative 3. So other than checking it, that leaves us with just rewriting it, and xy is going to be negative 3, comma, negative 4. And I'll let you check this on your own, but it's basically like negative 9 minus 16 does become negative 25, and then negative 6 plus 12 does become 6. So that's good for this first one. Okay, let's get problem 2 written down. 5x minus 3y equals 6. I also like this whole rewriting deal because it makes you think about the numbers involved. Maybe a little bit. Okay, now what can we do to these equations to get them to match up? You can either change x or change y, but I think that I'm going to like to take the first equation and the second equation and shoot for x. So I know that I could get 5 to become 10 by doubling it, and since I can get 2 also to become 10, I think we're going to target 10. So I'm going to take 5 times 2 to get 10, but then in the second equation, I'm going to multiply it by a 5, and then like I've been saying, not just 5, but a negative 5. So that when I move to the second equation, the first equation gives me 10x minus 6y equals 12, and then in the second equation, negative 10x plus 25y equals 5 times 10 is negative 50. With these stacked up, 10x gets eliminated, and we are left with 25 minus 6, which is 19y. Now, the unfortunate consequence of multiplying both equations is that you really just kind of end up with larger numbers in both of them. So then I do 50 minus 12 is 38. Got to make sure I keep it negative. That's another area where you can commonly make a mistake. Divide by 19, and maybe you're getting that warm, fuzzy feeling of having a nice integer there and not a fraction. So I got y is negative 2. I will plug this into the first equation and probably not overthink it too much. Minus 3 times a negative 2 equals 6. Then I'm left with 5x plus 6 is 6. Take 6 away from both sides, and then I get 5x is 0. No need to really divide here, as long as you're okay being like, well, then it just has to be 0. So x, y equals 0, comma, negative 2. Box it. All right, now let's see if this worked out. 5 times 0 goes away, and then a negative 3 times a negative 2 does give you positive 6, which is positive 6. It's always nice when you get a 0 for one of these because they usually are easier to check. 2 times 0 goes away, and a negative 5 times a negative 2 gives you a positive 10. So I've checked both equations, and this does work out in both of them. Here's problem 3. I'm going to scribble through here and here to not get us tripped up on which problem I'm talking about. Let's go ahead and let problem 3 be an on-your-own problem. And I am also going to sub out x for A and y for B. So if you really want to match what I do, you'll want to rewrite this with x's and y's. I'm going to put the answer up in 5 seconds. I chose to get rid of y in these equations and not x as a first step. I kind of just wanted to have, 6 and 4 felt stranger than dealing with 2 and 3, that's all. So here's the rewriting and planning step. Here's the changed equations where the y's were eliminated. Here's negative 1. And here's plugging that back in to figure out what y is. And summarizing the answer. And I went ahead and I checked it in both equations, and it is accurate. If you went about it a different route, you should still get the same result. So if you got a different result than negative 1, 4, be sure to ask me questions if you have them.